In section 4.5, we graph the sine and the cosine curve. In section 4.6, we're going to graph the other four trigonometric functions. Let's get started. For our first function, we're going to talk about how to graph the cosecant. Since the cosecant is the reciprocal of the sine curve, all we have to do to graph it is flip the sine curve. To make that happen, we're going to be drawing some asymptotes, and we'll discuss in a second where those go. And we're going to take the actual blue function that is the sine curve and then flip it to become the cosecant. So this green curve is going to represent the cosecant. And it's important to note that it stays within the asymptotes and it touches the sine curve at either a maximum or a minimum. We're going to be using those two properties that help us sketch this graph. Again, keeping it within the asymptotes and then touching at a max or a min. To see how all that happens, again we note that the cosecant is equal to 1 over the sine of x. And that's how we're going to generate our function. The domain is going to be all real numbers, which is the same for the sine and the cosine curve. The range is going to be going from -1 to negative infinity, and then from 1 to positive infinity. So it's kind of the opposite of the sine. And the period, in this case, is actually only pi. It's a little bit shorter. And number 4 here, this important part, are vertical asymptotes. Those are going to happen at every multiple of pi. So at 1 pi, 2 pi, 3 pi, 4 pi, and so on. And the reason why it happens there is because that's where the sine curve equals 0. If you flip that, you get 1 over 0, which doesn't exist. That's why we have our asymptotes. So we're going to draw our asymptotes again at every multiple of pi, and then we're just going to connect our graph to the maximum points or the minimum points of the sine curve. So the easiest way to do this is to start by graphing the sine curve, draw your asymptotes, and then draw these portions of the cosecant graph in between the asymptotes touching those points. And that's what we're going to do in class tomorrow. The cosine and secant graph interact in a similar way. To begin with, we have our cosine graph, which is this blue function. And once we have that graph, we're going to then draw our asymptotes, which will again go through where we have our intercepts. And the secant graph is then going to be graphed in between the asymptotes, touching down at, again, maximums or minimums for the cosine graph. So again, we're going to graph the original cosine graph, insert our asymptotes, and then create the secant graph afterwards. In order to create our secant graph, again, we'll go over some of the properties. The domain is again all real numbers, as it is for the other trig functions. The range goes from negative infinity to -1, and then 1 to infinity, just like the cosecant graph. The period is again pi, and this time our asymptotes are going to be at every multiple of pi over 2. So we start at pi over 2, and then we go to 3 pi over 2, then 5 pi over 2, then 7 pi over 2, and so on. And again, this is because the cosine graph equals 0 at pi over 2 and 3 pi over 2, and every multiple added to that. So again, just to recap, we're going to start by graphing the cosine curve. Then we would add in our asymptotes where our intercepts are, and finally create the secant graph connecting the minimums or maximums, and then again staying in between those asymptotes. I'm going to shift gears here a little bit to talk about the tangent function. Domain is again all real numbers. The range is from negative infinity to positive infinity. The period is pi. And here the asymptotes are going to again be at every multiple added to pi over 2. So we start with 1 pi over 2, then we have 3 pi over 2, then we have 5 pi over 2, and so on. In this case, though, the tangent function looks a little different. We don't have to worry about graphing a separate function. It's just always increasing, and it's going to cross over the x-axis halfway in between the asymptotes. So our first asymptote here is at pi over 2. The next one's at 3 pi over 2. They're going to cross over then at pi. And we just sketch the function increasing, crossing through at an intercept, and continuing to increase. Tomorrow we're going to talk a lot more about how to graph this, but for now we want to know the shape is increasing, and our asymptotes start at pi over 2, and then we add a whole number to get to the next asymptote. And our last function to graph today is the cotangent function. Again, the cotangent is the reciprocal of the tangent function, so it makes sense that we would just flip that. If you flip that, we're going to have a decreasing function. Again, it's going to cross through in between the asymptotes. And our asymptotes this time are going to be at multiples of pi. So we have at 1 pi, 2 pi, 3 pi, 4 pi, and so on. And again, this is because if you look at a ratio, sine or cosine over sine, the sign is 0 at values of pi, giving us asymptotes at those values. Okay, tomorrow in class we're going to be discussing again in more detail how to graph the secant, cosecant, tangent, and cotangent, and we'll talk about how shifts affect those as well. But for today, hopefully you know the shapes, the asymptotes, and then how to generally sketch them.